This lesson, we will discuss the paving and surface treatments for asphalt and concrete, and we will cover chapters 7 and 8 in the textbook. And we have three learning objectives. The first one, we categorize equipment used for asphalt and concrete paving. We determine the key parameters for bituminous distributors and asphalt pavers. And finally, we estimate the production and cost of concrete paving. Talk about the asphalt paving. Uh, Typically, there are different type of equipments, and that listed in here is sweeper broom to prepare for the surface. We need asphalt distributor. We need the whole unit, in this case the trucks, to carry the asphalt from the plant to the site, and material transfer vehicles. We need paver on site, and after paver we need compaction. Roller compactors will be required. And the next few slides I show you several equipment and how the operation of the asphalt pavement work. Some of this concept you learn in civil engineering materials. Just good to recap what is that about. So in some of the equipment for asphalt paving, as you can see, a different application, different material. In this case, for the liquid asphalt, then we can have that distributor shown here, and it also the asphalt paver with the transfer the asphalt from the truck, the whole unit, to the paver. It can also have a continuous operation with the change of equipment as shown in the bottom of the finger. So basically, there are multiple ways that can do the pavement with the level of technology utilized are different, and of course the application also different for different type of asphalt as shown in the bottom finger, or this either bituminous liquid, then the different equipment there. In terms of the operation of asphalt paving, this process show a whole cycle of the operation. The first, we need the material, is the asphalt from the plant, and to carry that we need a truck to the plant, and then from that one it have loaded to the truck, and then the truck will carry the asphalt to the site, to the road that need paving, and then we'll have an asphalt paver to pay the asphalt. And then when you pay, we need a roller to compact that, and then when that way we need to check the density, just like a compaction for the soil that we learned in lesson 5. And then this one we also still need to check whether the density that we apply on the field meet the specification required by engineers. So those are the process. And in this case, the two critical choke points that normally need to consider, because to improve the efficiency, we want to have a continuous operations. So what does that mean? Continuous, it means the balance between the production at the asphalt and the production of the pavement on site. So with that, we need to consider two choke points of bottleneck. The first is the link between the plant and the truck, so that it load, no waiting time in there. And then when the truck go out to the site, the link between the truck and the paver, asphalt paver, also have to be considered to ensure the smooth continuous operation. You don't want to have a waiting time for the truck or things like that. And that we will discuss in the next few lesson videos in terms of balancing the distribution and the operation of the asphalt. And for the before we pavement for the asphalt, we need some preparation. And in this slide, I show you a few equipment that need to be used to prepare for the base and the mat. For example, if you want to remove the old asphalt, then we need to have asphalt milling machines to dig out, and then to recycle the asphalt, and that you learn the recycle aggregate, recycles, asphalt, concrete, all of that in civil material. We also need to have clean the surface because we pave, that is pavement sweepers, and we also to connect the, the old layer of the asphalt or the base course to the top. We need to have a liquid asphalt distributor so that we have a good connection, good bonding between the layer of the asphalt, and that's shown in that equipment here. So with that, to prepare, how can we do that? As mentioned in the previous slide, we talked about the liquid asphalt distributor, and we used to distribute the liquid asphalt for two scenarios. The first, you have a base course, basically the soil in here, the base course. And then before we put the asphalt, which you see far end of the asphalt here, and in here we need to have the prime coat, so that have a bonding between the base course and the new layer of asphalt. So that what we talking about, prime coat. And then sometimes we already have the existing pavement, so it already asphalt here. We want to have overlay another maybe thinner surface of the asphalt, then we call it tack coat, and that so in the bottom finger. So as you can see, we need the depends on the where the asphalt to be applied. We call that a prime coat if that coat apply on the base course directly. If the liquid asphalt distributed on the old existing asphalt, then we call that a tack coat. How to distribute? Basically, two important considerations that's shown here. The first is the asphalt temperature. What is temperature required? Hot, warm, etc. And then the application rate. How much we need to distribute. And that will show you in the next equation how to what its application rate should be, and that involved with the spray bar. So that one here, you see the spray bar in here with the measure what is the width of the distribution of that distributor, and it will be used in the next equation that I'm showing you. So that let's go to the equation for the application rate for asphalt distributor. And like I said, one of the two considerations is the application rate. The other is the temperature, hot, warm, etc. Then application rate is your functions of the spray bar length, that what I just show you in here, spray bar length of the equipment. And then it also travel speed. If you speed go higher speed, then we need more application rate. If it slow, less application rate. With the same density we want, same unit weight we want on the application. And the pump output, measured by gallon per minute, etc. From that application rate with that functions, we come up with the equation in the textbook that the necessary road speed, which is travel speed for the asphalt distributor, and that stands for S, and S equal to 9, this is not G, 9 times P, which is the pump output, gallon per minute, and W capital, that is spray bar length, spray bar length or spray bar width, and that in measure in feet. So that is for the equipment itself. And R is the application rate measured by gallon per square yard. So that a little bit feet here, feet, and then here application rate for gallon per square yard. So you can see that different unit apply, and that's why you put 9 here. 9 basically 9 square feet per square yard. So that is the unit conversion. So basically, when we do on the field, the application on the surface, it measured by square yard. So 1 yard, that's square yard. And then we, with that equation, we can transfer that to determine the length of cover surface. So because we want to do, okay, for how long I can apply with the total gallon of asphalt, liquid asphalt on the distributor. We have that capacity, okay? So how many gallon we already know on that equipment. Then I want to determine how far I can distribute on the road. So that have the equation L equal to 9, unit conversion for 9, T, W small, uppercase, lowercase, and then R still application rate, gallon per square yard. T, total gallon to be applied, normally that how much the distributor, asphalt distributor carry, and the coverage width, that W lowercase, you see from the equipment itself, spray bar width either from the equipment itself, but with W here, sometimes you have to change, for example, change for one lane, then if it cover one lane for the distributor when they go for one lane, then whatever the width of that lane, it become the W lowercase in that equation. So with that, we can go to the next video to apply this to determine the total gallons to be applied with certain segment of the road